Hey everybody, welcome to the 3D Print Air channel. Today I wanted to go over an interesting spreadsheet I made for speccing out quadcopter hardware. What you've got here are the most common and popular quadcopters all the way up to the heavy lift quadcopters that are being developed to carry personnel. And I'm just recording all the nuts and bolts for everything I can find here. Just really the nuts and bolts of what everything makes everything fly. So the actual stator dimensions for the motors being used, the kV, which is the amount the motor spins per voltage you give it, uh, propeller diameters, pitch, propeller blade numbers, battery sizes and weight, and C rating, and voltage, and the drone weight. And I'm including information where I got this information as well, along with max speed and max flight time. So I haven't been able to incorporate all this information yet, like the speed and flight times, because I'm mostly just focusing on the hovering qualities of the quadcopters. And you can expand this data just by multiplying it to get more complicated information like single motor volume, propeller disc, total propeller disc area, battery weight percentage. And here is an interesting column expanding the power available from each battery pack the drone has by assuming the C rating is 35C for every drone. This is pretty useful because there's two reasons a quadcopter might have a certain battery size, and one of them is to increase the flight time, and another one is to have a large enough battery to not catch on fire when it's flying around. So there's definitely a significant trend uh, between the all-up weight and the power required at 35C based on the battery C rating and capacity, and we'll get to that later. And of course, go disk loading, and here's a bunch of other variables that I was messing around with and couldn't find any correlations with, but except for this one, disk loading times motor number divided by propeller number, which I think is which I found was correlated with the KV. And if it sounds random, uh, you know, the correlation would argue against that. But if you conceptualize it, the disk loading times the motor number, the more motors you have, the higher the KV is going to be. If you're built to hover, and the larger the prop diameter is, the lower the KV is going to be. So multiplying what would increase the KV, dividing by what would divide it, and including the disk loading in there. So what that leads to is all these graphs. And there's a lot of great correlations you can get just with the motor volume, which is exceptionally great considering, this is such a large range of quadcopters, like literally from a Mavic all the way up to something that's flying a person around. And I don't think that should be the case. I think in the future there should be spreadsheets for up to 2-inch quads, 3 to 5 inch, 7 to or 6 to 12 inch, 12 inch to 55 pounds, and then kind of, um, yeah, maybe it would be better to separate it by weight. But essentially, what I'm saying is things change. Things are not remaining the same over these weights, right? Like some of the more expensive drones use lithium ion batteries. The cheaper ones don't, and all that stuff's going to impact these correlations. And the Reynolds number is going to be much more favorable for larger craft, and smaller craft won't have that. So the fact that it's working so well with this large scale really shows how dependable it is, at least in this domain. So the first one is total motor volume. So basically, the stator volume is always correlated with the all-up weight because the stator is what's creating the power for the drone in the most part. It's what's getting saturated and with heat and heated up by the power of the motor and the power required by the propeller. So And these are all just linear regressions, so it's extremely simple, which uh, goes to show how, I mean, you can do logarithmics, but it's really not that complicated when you boil it down to nuts and bolts. It's pretty much just y equals mx plus b correlation. And that's it right there. 4.46 times the uh, x-axis is mislabeled there. Excuse me. But 4.6 times the all-up weight in grams plus 37,886. And that will give you the total motor volume that a quadcopter could fly with and would likely work pretty well with. And the same goes for the KV. You just plug in the disk loading times motor number divided by the propeller, and you can get what kind of KV you should be aiming for. So this is kind of a rough area because when you get such a large domain, the actual KVs at the top end up getting like really low. So this is an area where I think it'd be better if there were a spreadsheet only including like drones 2 inches and below width, because or if drones 55 pounds and up, because if your data is based on a whole bunch of human carrying drones, and then you try to, or if your data is based off a whole bunch of like tiny camera drones and you try to calculate the KV needed for a big drone, you might get like negative number and it can create errors in your spreadsheet like down the line. So that's kind of the usefulness, I think, of having uh, breaking it down into sections like that. Um, but that's a lot of data requiring, and I think it'd be better if the community looked at that. Um, which is why I'll have these spreadsheets available on my Patreon. I'll have a community spreadsheet and XLSX download for everyone. Uh, what else is there to go over here? Disk loading. Yeah, this is the disk loading. Not sure if I'm using this in anything currently. Uh, total prop area, that's another big one with a total motor volume. And the power requirement versus all up weight is another really essential piece of information. And you could take all that data and basically just say, well, if we have control over these knobs right here, we can determine everything else. And this is really cool because if your drone has 4 propellers, 6 propellers, 8 propellers, it doesn't matter as long as as long as the all up weight and the total of everything fits into the linear regressions, then it should work because all these inputs have different motor numbers and they fit together great. And another thing I did was plug in the aspect ratio for the stator of the motor back into the cylindrical volume equation. So I took the height out of the equation and just put the aspect ratio in. So the input is the motor number and the motor aspect ratio. And that way, let's say if you have like I don't know, a 10 kilogram drone. So that would be 10,000 grams. You're trying to find a motor for your drone. You don't know what to do. Maybe the popular solution isn't working very well, or maybe you want to see how that popular solution compares to what this says. You say like, oh, I want to build a X8, so you say 8 motors, and the motor stator volume. That's kind of hard to interpret, but the stator diameter and height are what you can use here to actually shop for the motor. So 54, 43. Now you might want to look for like a 60-40 or something close to that, but you can actually adjust the motor aspect ratio to kind of find what's best. And of course, um, depending on your application, you might need like a efficient disc motor or a powerful cylinder motor, but this can be really good for just finding the solution, and especially unorthodox solutions. So I'm gonna just vary the motor aspect ratio. So say you want like a pancake motor because you're concerned about efficiency. Go find an 80-20 at 500 kV for a propeller diameter of 13 inches. There's your X8. Try that out. and you could just up the motor number like 32 motors. So 32 6-inch propellers, and you can carry your 10 kilograms around. So I, I think it it's not it's not really like aeroscience, but it still is math. And going through like designing regional jets in school, they just give you books with a whole bunch of cheat sheets like this for designing regional jets, and that's how the big guys start out doing it too. And I just think there should be something out there like this for quadcopters. So yeah, it's pretty useful. You've got your propeller diameter, your motor KVs, all the important things here highlighted, and you can kind of judge the battery as well. Suggest a voltage. So where would that be? Yeah, voltage to burst without a fire. So you're going to want to stay above 2S, obviously, and you can input the milliamp hours as well. So if you're going to carry, that's why it's suggesting only 2S now, is because you've got a huge battery that I was using for a larger quad. So if you say, well, I only have 1300 milliamp hours, the voltage requirement is going to go way up there. And that helps you really explore with different battery chemistries, which you see down below here. You have full adjustment over the cell voltage. So it'll give you a cell count over here. And you have full adjustment over a specific energy density and specific power, this graph can kind of help you get. I'm not a chemist, but I found this online, and you can just plug it in. Yeah, it's really helpful because I mean, lithium ion is really great, but you want to make sure that with your C rating, that it's actually going to be able to supply the average power requirement for your weight class. So yeah, I think it's really interesting, and I really hope somebody appreciates this. I'm really interested to see what the community can do. I would suggest if you do put information in, it could get really, like all of these are well designed solutions, right? So if like someone puts together like a Lego quad, maybe you wouldn't want to like design linear regressions around it, like the include like well designed solutions in here, and you'll get well designed solutions out. Is the theory. Um, and include, if you do include information, and even if you're not sure, or if you're not sure about it, or even if you're sure about it, just include it in the comment, and then that way someone can see, because especially for these larger things, these are going to be harder to research. And I think they should be in their own separate tab, but I would still like to have a sheet with everything in it, just for the sake, because you can do exponential and logarithmic fits as well without much more difficulty. It's just a button in the sheet. So I would like to say also that you have to update the numbers here. So if the linear regressions change here, you have to change them in the formula. So maybe someone knows how to do that. If you do, leave it in the comments below. Yeah, I'm gonna be coming out with more videos soon. I've got the fan testing coming up, and as well, I'm developing a fan hub for the Noctua fan as well. So if you're interested in that, get subscribed. Comment below what you think I can do with this spreadsheet, or how you think that I could improve it. Let me know if you've seen a resource like this before. Hit the like and subscribe button, and I'll leave a link to my Patreon below as well if anybody would like to support research like this. Like I said, all the equations are right here if you need them, but I will have this linked in my Patreon. So thanks everybody, and I'll see you in the next video. Peace.